I'd like to welcome you to this evening's program. My name is Beth. I'm the Community Programming Librarian for the Mid-Continent Public Libraries. I would like to introduce our presenter this evening. Mr. Wright has been an astronomer for many years. He is on the staff at Steward Observatory at the University of Arizona in Tucson. His passion for astronomy took root as a teenager while camping at the H. Roe Bartle Scout Reservation under dark skies where he shared his telescope. This passion continued into adulthood when he joined the ASKC in 1997. He became Power Observatory Director in 2000 and President in 2004. In 2005, Mr. Wright became the Operations Manager of the Warkaszewski Observatory.
Warkaszewski.
I was not even close. At UMKC. And in 2016, he flew missions on NASA's Sophia Observatory. So with that, I'm going to mute myself and let's welcome.
Well, thank you everybody for being here. I want to thank, of course, the library system for having us. I want to thank my wife. She comes and helps Rita in the back room. Of course, I want to thank Beth, and I had her name earlier, Dawn. I kept saying it, then it goes out of the head, for hosting us tonight, especially Beth for doing the technology, but really the people here in the room and online were taking an interest in this. Let's face it, our ancestors grew up under the night sky. All right, they sat around and told stories. That's how things got handed down. There's cave drawings of the sky that we know of. And so we've kind of lost that because now we stay inside such nice places, homes, buildings and stuff, that we light up the sky with light pollution and we don't see what our ancestors got to see. So tonight on this Connecting the Dots, to talk about a little about mythology, I'm going to try to do it two ways. And I decided to do this year. A little mythology of some of the star patterns and constellations, but I also want to show you some software that you can download at home that is excellent for astronomy. And maybe that will continue your interest in this, that when you see something up, hey, what's that in the west at sunset? You can actually bring up this software and it will tell you, is that a star? Is that a planet? And you'll be able to take this with you anywhere you go if you have a computer, a laptop, PC, a MacBook, or even a Linux system. So you can download this to any of those three systems. And every year they keep developing this more and more. And it's really a good educational tool. And we've seen it used at the University of Arizona for teaching. So I want to show you that also. I think that's the most important thing tonight that we will do. As Beth said, it's hybrids, so it's a little bit different. And pardon me for not walking around like I normally do, but since it is hybrid, I'm going to kind of stay over here. And I was going to tease you and say, Beth and Dawn, we ought to pick up the yellow sheet in the center with the $20 bill under it since nobody sat there. And someday we might actually do that. So, and then remember, hold your questions to the end. I will repeat the questions for any of them that are here live. So our listeners and viewers and patrons of the library can hear the questions and also listen to the answer. All right, connecting the dots. And, oh, can we dim the lights some in here? So while Dawn is dimming the lights, do you recognize any patterns in this photo? This picture? I know you didn't know there's going to be a quiz. So, okay, tell me what you see. Yeah, in the middle. And since we're online, I'll use let me get up here so we can be together. So we have a dipper. Now, is this a constellation? Well, and she's saying the correct thing. Ursa Major and Ursa Minor are the actual constellation, but we recognize this as a pattern that we call an asterism as our dipper. And if you were in Boy Scouts, one of the requirements for the first class rank is to use the dipper. We have the handle here of the Big Dipper, and then the actual ladle part, and you draw a straight line down here, and you connect the Polaris. And that was one of the requirements for the first class rank. And you find sorry about that, the mouse had disappeared. You find the Polaris, our pole star, the North Star, and its handle turns opposite, okay, and down into the Little Dipper, which is part of Ursa Major and Ursa Minor. Are there any other constellations or asterisms you might recognize? Sure is harder without the lines, isn't it?
Next to the Dipper.
Through to the right?
Yeah.
Okay, and here?
Yeah.
All right, what do you see?
That's like,
Yeah, Draco, it serpentines a ways through here. And then you have over here Auriga and its right star Capella. And then we get over to Castor and Pollux and the twins, Gemini, or as NASA said it for the program before Apollo, Gemini. So that's what we're going to be talking about, some of those constellations and asterism tonight. And we'll be taking a look at those. So I also want to say I'm with the National Sharing the Sky Foundation. Many of you may remember back in the mid-90s, the comet came through our solar system. It got tugged by Jupiter, our largest planet, and pulled apart. And David Levy there in the photograph was part of the team, the Schumacher-Levy 9 with Gene and Carolyn Shoemaker, which Gene was the person who trained the Apollo astronauts in lunar geology. And they were comet hunting and they found this. And of course, it opened up the eyes of the world because on the way out of the solar system, the comet was tugged apart into 22 pieces on the way in. And on the way out, it slammed into Jupiter. And it was humans' first opportunity to see an impact on another planet, or really any planet, because we haven't witnessed an impact before. So that really opened up the world's eyes to really start looking for these things. When is our turn? And he started the Sharing the Sky Foundation. And just a few years ago, David asked me to take over the leadership of this foundation, and we moved it to Kansas City. And if you have heard of David Levy, he started observing when he was around 10. And he has notes from that time until his 70s. He's still alive, still observing. And his first telescope and his notes are on display down at the Linda Hall Library on the campus of UMKC, where you can go and see these. And so he was one of the most prolific comet discoverers, around 23 discoveries of comets, and I don't know how many asteroids, and has written nearly 35 books. So in the astronomy world, he's a pretty big guy. And he's never had an astronomy class. So I let kids know this, that, you know, you can still do great things without necessarily being formally educated. Astronomy is one of the sciences that it really is pro-am. You don't want to study medicine as pro-am and be your own doctor. We see how that turns out. So I just wanted to mention that. And I should have put my thing in advance, or been easier. So as Beth mentioned, this is Powell Observatory in the upper left-hand corner. It's at Lewisburg, Kansas, open to the public on Saturday nights for a small donation. And then down, what's that? May through October, yes, May through October. And it has a 30-inch telescope in the dome, a 16 and a 12-inch out there in the roll-off shed. And then many times members will bring their telescopes down for people to come down and look through a variety of different telescopes. So check out the ASKC, means Astronomical Society of Kansas City. We couldn't come up with a shorter name. So askc.org, and you can find out information about that observatory and the one I'll show you on the next slide. And then I like showing this one at Stewart Observatory, which is up at Mount Lemmon and Mount Bigelow. This is one of the telescopes Rhea and I get to use and I'm trained on. And this is a 60-inch diameter telescope that was built specifically for studying the moon for Apollo landing sites. So it's really cool to be able to use a historic instrument that was picked and built for studying for the Apollo program. We feel very fortunate to be a part of that. And here's Sophia. This is the Airborne Observatory I flew missions on. The jacket that I am wearing was the official NASA astronaut's jacket that they issued me with my wings for flying on this. You can see in the door opening the 8-foot diameter telescope. This flew only at night, and it only imaged an infrared light, the infrared spectrum of the light, the electromagnetic spectrum, which goes from radio to gamma rays. And if you really want to know what infrared light is, well, you know, one, heat is infrared light, and many of your devices in your home work with infrared remote controls. So if you activate your cell phone and it doesn't have an IR blocker, you can actually point a remote control at your cell phone camera, and you can see the flashing light of that remote device that your eyes do not detect. Unfortunately, it has since been retired before I made more flights on it. And it is down now at the Pima Air Museum in Tucson, Arizona, being prepared for visitors to go through it. So it was really nice to be able to fly on that as part of my education as an astronomer and educator. And finally, observatories, the Dvorkachevsky, which we lovingly shortly call Warco. This is on top of Royal Hall at UMKC at 52nd and Rock Hill Road. It is open May through October, Friday nights, weather permitting. It is absolutely free to the public. You do have to be able to go upstairs to get to the observatory since it's on the roof and you have to go through the roof hatch. Well, it's a wide opening, so it's not like a ship's scuttle you have to go through. And that big scope in the center is a 16-inch diameter telescope that has an exquisitely made, handmade mirror that gives you the best views of solar system objects in this region. And it was made by a gentleman for his wife. She was the astronomer in the 50s. They had it in their backyard at just off of 70th and Truce for many years before they donated it to the school and opened the observatory in 1974. So this is the 49th year that the observatory has been open to the public. So come down and visit us. Opening time, of course, changes with sunset, but it closes promptly at 11 p.m. Actually, you want to make sure that when you get down there before 10 p.m. because there's a chance the doors to the bridge that comes into the Royal Hall from the parking garage might be locked for security reasons. Okay, so come on down. We have up in the upper left-hand corner, you can see we have a 14-inch telescope. Over here is a 10-inch, and then we have the 16 here in the center. And there's no reservations or anything, just come on down. Okay. So the goals tonight, one is go over some mythology, see what we know about and grew up with, common bad myths or ideas about the constellations and stars, and also introduce you to a planisphere. Those who are here in the room have an opportunity to make a planisphere, which is a star chart that you can use, and every astronomer has one, and introduce you to Stellarium, a free planetarium software package that is used by many universities and colleges for teaching undergraduates in their first year of astronomy. And also to inspire you to go out with your family, your neighbors and stuff. Have a backyard star party with your friends and family and do some stargazing, or even, the moon's a beautiful object with binoculars. You'd be amazed what you can see with handheld binoculars. All right. Star charts, patterns, and constellations. Every constellation has a defined area, region that it occupies. On star charts, and I'm going over this because hopefully you will be using a star chart or stellarium, the brightness, or what we call magnitude, of the stars are denoted by the size of the dots that represents the stars. And it is not a linear progression, like the difference from 1 to 6 means it's a difference of 5 in being dimmer or brighter. It's exponential, logarithmic. So going from 1 to 6 is a difference of 5, but it's 2.51 raised to the 5th power. So a difference from 1 to 6 means there's a difference of 100 times in either dimming or brightness, illumination, depending on which way you're going. So if we're looking at the star chart, you can see that this star here that happens to be named Vega, one of the bright ones, well, it would be near an O magnitude star. That's how bright it is. Well, then you get to one of these others down here, maybe like one of these little dots here, that could be, oh, here's probably about a 4. Okay, that's a difference of 5 times, right? 0 to 4. So that means this star here that I was pointing at is 100 times fainter than this star. So when people ask astronomers, well, how far can you see? Well, how bright is the object? Is it really far away and really bright, or is it close and really dim? It's just not a distance, it's how bright of an object we're looking at. Also, as you noted earlier, and we all commented on, there's no lines on in the sky. Okay, that's a man-made thing, of course. And you'll find different charts actually connect the dots a little bit differently sometimes. So that might throw you off if you go out and buy a professionally made plastic planisphere. But like I said, our ancestors have been doing this for nearly 4,000 years. You know, naming the stars, keeping a track of how things move. In fact, in Greek, the word planet means wanderer. The planets wandered through the sky. So, and this is what we would call from Sky and Telescope magazine and the International Astronomical Union, and you can actually purchase charts like this. Some of them are about 12 by 18 inches that show it in either a white background or a black background. If you get into astronomy, maybe down the road when you have some experience, you want to get more of a more accurate chart. And this is one you'd use with a telescope to find things, because you can see that there's little objects up here that are colored in. Those are what we call the deep sky things. Those are galaxies, star clusters, gas clouds called nebula. So these charts give us a lot of information, just like a road map we get, or I guess used to get. Some states don't make them anymore, and I like collecting maps. And so all that information, all that's put on whatever level of star chart you decide to get. So your first task, remember all 88 of these. You got 30 seconds to write all these down. So this is the official list of all the constellations. And that organization that I alluded to a moment ago, the International Astronomical Union, which is up there, and I used to be on the educational committee of that group. They are the ones that name everything in the universe. I don't mean to offend anybody, but the Star Registry is not the official namer. These people are. But we understand people buy those things to honor somebody. So, but this is the official group. These are all the constellations in English that's been translated, and you can see some of them have the Latin name. They all have their Latin name, then they're translated with what they are. And if you look through some of them, you'll say, well, I have never, ever heard of that constellation. That's because it's southern sky. Okay, we will never see the southern sky in Kansas City, Missouri. As you travel farther south on our planet, which is a ball, right? It's not flat. The stars in the north get lower in the northern horizon as the stars in the south start coming up. So has anyone ever been to Florida? Cancun? If you ever been down there, I've never been to either place, you'll notice like Scorpius, which is on our southern horizon, is up higher in the sky. And that's because you're moving south, farther south on our planet. So when you get down into the southern hemisphere, their stars, they have the same flip-flop. There are constellations that people in Australia will never see because they're south of the equator. But I'm sure you're familiar with most of these. The circle of animals, Zodiacos Clykos, which means the ring of animals. But how many are actually listed up there? How many, and typically astronomers don't get into astrology, but these are constellations. Is there one up there you really haven't heard of before? That sounds goofy? Yeah. It just like saying Vorkachevsky, how do you say this thing here? Right here, Ophiuchus. So that was actually a zodiac constellation years ago. In fact, centuries ago. And then a few years ago, the news picked up on it about, hey, there's really 13. But let's face it, it was in a small window where the sun passes, as the sun passes through the sky, because of the wobble of our Earth, we're looking at a different area of sky in the sun. Like the old song, The Age of Aquarius. Well, the sun was in Aquarius. Well, for a short period of time, the sun would be in Ophiuchus, and they decided, let's just divide it up between the constellations on each side of it. We'll get rid of it, knock it out of there. There's 12. 12 divides nicely into 360. We got it made. And so that's pretty much what happened. So, and that hit the news a few years ago, the local news, and we astronomers knew about it. But that is actually the 13th constellation of the zodiac that they had. And you can see the classical art figures over on the right. And so what I'm talking, in fact, diagram up there shows when I say the sun appears to be in that constellation, that's what it means. Just like at night, the planets appear to be in a particular constellation, right? It's just that the stars are so far away and the planets are in front passing through as we rotate around and revolve around the sun, so do the other planets. And so we see them at different times in different constellations. Okay. Our celestial pole, I mentioned it earlier. And by the way, all these images here that you see of the night sky are taken from the software that I'm going to show you. These are screen captures from the software that I use to put this program together. And we already talked about the pole star, Polaris, that if we draw the lines, that we use the two asterisms, and then we connect to Polaris. Now, years ago, 4,000 years ago, as Beth was saying, Draco, well, the star in Draco, Thuban, was our pole star. And a few thousand years from now, Vega will be our pole star. That's because our Earth wobbles just like a spinning top. Right now, we're pointed over in this direction. Well, later on in our what's called precession, we're going to be pointed in another part of the sky where our pole star will change. Now, the $100 question, if we had $100 to give away, what other name does the North Star have that's famous? Especially during, let's say 1850s to 1880s. It was called the Freedom Star. The slaves okay, talking about mythology, they told stories how to escape, follow the freedom star to the north. So see, there's let's call it a modern twist on some mythology that now it's just not our pole star, it's the freedom star because it points to the north of freedom. And that's the storyline with Harriet Tubman, right? She would lead the Underground Railroad and they would tell these stories of different, mythologies to other people, but they understood it to be follow the freedom star, Polaris, to the northern states. And and again, here's some of the artwork, and we will show you this in Stellarium. And you can see, you wonder, okay, what were our ancestors really thinking? What were they doing around those fires to come up with some of these figures and stories? And some of the constellations only have, one or three, four stars, and they have a constellation with it. And this is, like I said, the classical artwork. You can see Draco, Beth had mentioned earlier. You see Hercules on the upper right, Capella and Auriga that I mentioned. And I know the ladies over here and several others mention Ursa Major, Ursa Minor. And then down on the bottom, Cygnus, which actually is one of the ones that when you draw it, yeah, I can see where that could have outstretched wings of a swan, which is actually a representation of Zeus, by the way. Do we have anybody under 18 online? Under 18 online? Okay. Because, when you get into this mythology of the stories of these constellations and planets, a lot of it factors around Zeus and his philandering. And so you have to be careful with little kids how you mention that. And that arrow is just representing the rotation. For us, we're turning to the east on the planet. So the stars look like they're moving to our west. And of course, almost a month and a half, 2 months ago, they were talking about go outside and see the planets in a line. And so the planets follow this plane of the ecliptic within 8 degrees, except for Pluto, it's about 15 degrees away from it. So it is an oddball. And if some of you probably went out and looked at, you can see like 4 or 5 planets at sunset, and they would have followed this path. All right. So Ursa Major, the big bear, and the little bear. And you can't talk about one without the other because they're connected. These constellations are called circumpolar. They never completely set below our horizon. All right. So any given night, any part of that constellation between Ursa Major and Ursa Minor are going to be above the horizon. The story goes that Zeus, of course, I don't remember the exact names, had come upon, let's say, a fair maiden that he took interest in. And so he had a liaison with her, and she had a son. Well, Zeus's wife Hera found out, and here he is again doing this. Wasn't the first or the last time. And so she turns her into a bear. And the son is out hunting one day, and he forgets his mother was turned into a bear, and he's drawing his bow back to shoot this bear that he sees. And Zeus intervenes, not wanting him to kill his mother. And so in order to keep them two together, he swings them up into the sky by their tail. And if you look, that's a rather long tail for a bear, and that's part of the story, the tail stretch. But he put them up opposite each other so they would always be together in the night sky. Now that's one version. There are different versions depending on, just like stories we get in here, anywhere in the world, who tells it, who writes it down, what becomes most popular. And even in the Greek mythology, by region, they change a little bit. But that's the most accepted one. that Callisto was the sun, and Zeus put them both up in the sky and made them both bears so they'd be with each other forever. And you can see now how much, especially of the Big Dipper, how many more stars there are in the whole constellation compared to just the what we recognize as this asterism here. Okay. And even with binoculars, this star here is actually a double star. So with binoculars, you can see two stars close together right there. And you can see its head down here, its front paws, hind paws. So a lot of leeway on doing the artwork, but I think this is probably the first constellation that any of us or asterism learn as a child. And then again, that's just pointing to it again. Sorry for the redundancy. There's the Ursa Minor, and it really doesn't have a whole lot of more stars to it compared to the Big Bear, except for that famous star there at the end of its tail. Now, this lady here is probably one of the most interesting constellations and storylines there is. And some of you will remember in a moment when I mention the movies. So we have Cassiopeia. She's the queen of an area around Ethiopia. And if you can tell on the right, she's upside down. But can anyone guess what she's holding in her left hand? A mirror. All right, this is where I have problem with young people, because they're not so familiar with the word vainful. So they kind of know self-centered, but you know, full of themselves eludes them. But she is vainful that she is so beautiful, and then she says her daughter is the most beautiful between heaven and earth and of all the gods themselves. Well, now you got some other ladies over here, some nymphs that are related to Poseidon, takes exception to this. And her daughter is, well, this is her husband, Cepheus the king. He's seated in his throne, and it looks like the constellation actually looks like a house, stick house a child draws, right? Oh, I can down. Okay, I must have got my slide mixed up. So she boasts that Andromeda is the most beautiful woman in all the world. And the nymphs convince Poseidon to send the Kraken to destroy the city for their vainfulness and egotistical thoughts. And the story goes, Perseus, who is a hero, a demigod. In Greek mythology, a hero has one parent that is a god, and his is Zeus. Well, he offers to save Andromeda from being devoured by the Kraken, the sea monster. And it depends on which story you listen to. Was it Draco that they sent, or Cetus? But most of them believe use Cetus. And he says, well, I'll save your city, all your people, and Cassiopeia and Andromeda for her hand in marriage. And being a son of Zeus, he is given some special equipment through the gods. One was a shield that had a mirrored side, a sword, a special sword, and a helmet that made him invisible, and then a bag. And he went and visited the three sisters, the witches, to find out how to kill Medusa, the lady with the snake heads, head full of snakes. The ugliest thing that the story is that if you gaze upon her eyes, you will turn to stone. And so he goes off to fetch the head of Medusa, brings it back, and this is where some of the stories changed, that Perseus received Pegasus, the winged horse, before he left. Some stories say Pegasus sprang from the ocean when the blood of Medusa's head hit the water. But either way, he had the winged horse, brought the head back, showed it to the sea monster, turned the stone, just like classical TV, saves the city, the town, the young maiden marries her and goes off with her. Now, many of you might remember a movie called Clash of the Titans, and they made two of them. And just for the fun of it over the weekend, my wife and I watched both of them. And it still takes a little bit to watch them. But it was interesting how between the movies, even that has changed, where in the first movie, it went just as I said. And that's one of the storylines. The other one was that Io, which was actually a moon of Jupiter, but is also one of the liaisons that Jupiter had with a maiden, helped Perseus through his trials to go get Medusa's head. She was a demigod. The story on her was that she was immortal. And at the end of this movie, he leaves Andromeda and takes off with Io. So it's interesting, even in Hollywood, how they change things around to make it interesting. So you might check your local library, your local branch, depending on where you're at, see if they have the movies. I know some branches have the Clash of the Titan movies. Okay, somehow I got that out of sequence. Sorry about that. But we can talk about the lion. So how many of you know Leo, of course, from the zodiac? So the lion in our sky is thought to be the Nemean lion, which was killed by Hercules. And it was going around terrorizing a local village, killing cattle, humans, stuff like that. And then Hercules came and, through his club and sword, actually defeated the lion, took the skin as its cloak, and even at times wore it around. And so Zeus, even though the lion was, regarded as terrible, he thought it was such a magnificent creature that he put it in the sky. And since it took on Hercules. And the interesting thing is, some of that could still be going on today, because every once in a while in the news, we hear about a lion in Africa terrorizing a village to our present day, that they have a problem with this and they have to hunt the lion down because it has come into the village and taken somebody or caught somebody outside the village. And I just find that interesting, that after thousands of years, this type of thing can still be applied to our modern times. Cancer is another one of, and they go in line between Cancer, Leo, and Virgo. Gemini, Cancer, Leo, Virgo in the night sky. And Cancer, of course, is represented as a crab. And you can see on the left without the artwork that, yeah, I can see this as a crab. And this is one of the original 13 constellations of the zodiac. And despite being kind of a dim constellation, you can still pick it out. And there's still stories behind this, that during Hercules' 12 labors that he had to go through. And he went through these labors because Hercules didn't start off as a nice guy. And he was basically doing penance for doing, and had to go through these different labors to regain himself. And one of them was to take on this giant crab, which actually was sent by the goddess Hera to distract him while he was fighting another foe. And it was pinching at his toes. And so Hercules had to kill the crab in order to continue on. And one thing about this constellation, if you get outside the city lights with a pair of binoculars and look up there, there's a thing called the beehive cluster in Cancer. That is, when you look at it, it's basically we call it a globular cluster, that it has all these stars. And I hope I'm saying that right, not open cluster. It's been a while since I've looked at it. But still, there could be 100, 150 stars that you see, that it looks like a beehive with a swarm of bees flying around it. And it's a really neat object to take a look at, but you need to get outside the city lights. So I want to stop there. And what I want to do is go to the software. Okay. So give me a moment. I'm going to, in the PowerPoint, not the PowerPoint, the PowerPoint. I'm not ending the program, and reshare my screen. Apparently I did that wrong. Sorry, Beth. And bring you to this here. And I thought I can pull this out of the way. I don't know why I'm getting that, but we're going to go with it. Yeah, I'll minimize it. No, I can't. All right. So this is Stellarium. All I did was type in a few weeks ago. I was at one of the other branches looking up some books, and typed in Stellarium. It's Stellarium. And are we seeing it okay online?
Yep.
Okay. And it's about 350 megabytes for the Windows version. Still trying to hide some of this from everybody. We had all this worked out earlier, didn't we? That's how it goes. Over here, when you download it, it will self-extract and install. You have a set of menus for controlling the software and setting it up. This is good for any place. So, and that's why I wanted to show this to everybody instead of just telling you about it. I wanted to show you how to set it up and use it. I figured that would be more useful. So over here, the first icon, and it tells you, is for location. All right. As you can see, I have it set for Kansas City. Are you going on a trip? Are you going to Cancun, Australia, Argentina? You can set it up by scrolling through over here, hundreds of locations, or you can even put in a GPS location. All right, if I was going down to the Boy Scout camp near Osceola, I would put the GPS location for there. It really wouldn't be that much difference between Kansas City and Joplin. All right, so that's where you set up your location. Then you can set up the time and date. By the way, you can go back in time, or you can go forward in time. All right. So if you have children, you can show them what the sky was the day they were born. And print out a star map. You can say, do a screen capture and print it out. Then we start getting into the meat and potatoes of this thing. Okay. So the first thing is the sky. And okay, it looks pretty good up there. It looks pretty small on my screen, so I can put on cheaters. So this is where you start setting up what you see actually in the sky. Okay, this software is actually developed to be used in a planetarium with a dome. And it is freeware, and it works excellent on PCs and Macs. So here you can set the sky. How bright do you want the Milky Way to show up? There's even a thing called a zodiacal light. It's a light glow that goes with the ring of the zodiac animals, that the constellations through there. Over here on the right, you can set the scale of stars. Okay, how large and small do you want them? the twinkle. Don't put that twinkle up high. I have it at 0.2. I put it up higher and it's very irritating. So limiting magnitude. Remember that number I was talking about earlier about the stars, that between magnitude 1 and 6 is a difference of 100? Well, let's think about what we can see. Are we in Kansas City on top of the roof at Royal Hall, where maybe we can see down to magnitude 3? Are we out in the country out here, northeast of Kansas City, up by one of the state parks or wildlife areas where it's dark, and now we can see magnitude 5 or 6? So you can always change it. Or are you at Bryce Canyon, where it is extremely dark and there's so many stars I get lost? So that's where you can set your brightness of stars. And labels, okay? Also, and you'll see this here, labels and markers throughout the software, because I said there's a lot more than stars and planets in the sky. We have galaxies, star clusters, gas clouds, catalogs of these things, thousands and thousands of them. And you don't want to overpopulate your screen where all you see is the names for everything. So I keep that midway, okay? SSO, solar system objects. Well, this is where you can go in and, okay, how does it scale the moon and planets for you? Do you want them large or actual size so they look like pinpoints? Also, you can set up for comets and meteor showers on your view, because there are meteors every night. They're not necessarily a shower that is associated with the comet that came through our solar system thousands of years ago. They're sporadic meteors all the time. So you can set out how many per hour you want. And over here on the right, I talked about, again, limiting magnitude of the solar system objects. Also, the scaling of the planets. How big or small do you want them? And you can play around to your liking. And then, here again are the label. You can have icons to set up for the planets and stuff, the color of the planet. So if we click on that, you can pick a color that you want the little icon for a planet to be. I actually have that turned off, but I'll turn it on for right now. I'm going to try to go rather slow on this, so I hope I don't lose anybody. So that's solar system objects. And you can play around with these settings and find what best suits you. I'm still trying different things, and I've been using this for about 10 years. Deep sky. I mentioned comets or galaxies, star clusters, globular clusters, open clusters, nebula. So the top one are catalogs, all right? And I'm just going to leave the first one checked. This is for a guy named Charles Messier. 1700s, we got a comet hunter over in France, okay? It's dark skies everywhere back then, right? No light pollution other than what they had as far as if they had any lamps on the street, gas or whatever, kerosene. So he's hunting comets, and he runs across this thing, a fuzzy patch. Hey, that's not a comet. I'm going to write down its location, its coordinates. So now if I'm come back through this area sky again, I know not to be concerned with this object. It's not a comet. So he did this year after year where he got up to about 90 of these objects. And then he passed away, maybe got near 100. And then his student took over and continued on and added up to 110 of these things. Well, he's more famous for these objects that weren't comets than for the comets that he discovered. And it's called the Messier list. And some of these are binocular objects. And don't forget to check the stacks here in the library. I think it's around 360 or 460 on the Dewey Decimal System for their astronomy books. And I'm sure they might have one for backyard astronomy, binocular astronomy, something like that. And you'll see some of these things. The beehive cluster I mentioned earlier, M44. Messier object number 44. And it's a challenge for amateur astronomers to find all 110 of these objects with a telescope manually by hand with a star chart like I first showed you. We're finding 50 or 60 of them with binoculars, and there's an award you get for that. So I leave that on for you to take a look at. And in this area here is the filter of exactly what I just mentioned: galaxies, globular clusters, bright nebula, dark nebula. So these are the type of objects that will show up. And then and all these are other catalogs, by the way. You know, it's like Sears Roebuck. Well, you can't even say that anymore. There's no Sears Roebuck catalog. There's no Montgomery Awards catalog. My God, we don't get to have the Christmas catalog. But these are catalogs that other groups or people have put together. And C is for Caldwell. NGC is a popular one. It's one of the most comprehensive. It's got hundreds of objects. But I'm just going to leave Messier on there. And then over here is how you slide how much information you want to show. In fact, to give you an idea, I'm going to turn this off for a moment. I am going to move us forward in time. I figure out how to, and down here in this other menu, I'm coming over here to like the old cassette tape, and I'm going to push fast forward, and I'm going to move us in time. Each time I click, you notice it moves faster and faster. And I'm going to stop right there. That's about 9:20 tonight. All right. And while I'm doing that, I might as well have this on. So now that you can see, as I slide and move in, here's one of those Messier objects. As I move the slide bar, you see more and more of those pop in on our chart. And over here, there's a limiting magnitude. Well, there is no way that our eye is going to see 13. So I'm going to put this around, I can put this at 11. My smaller telescope could hit that. Your binoculars, maybe you set it for 5 or 6. So there are in the background, you can see here, some of those Messier objects that are coming up that I have noted on here. If I turn them off, you can see what I'm talking about, how that works. And we're going to take a look at some of these so you can see that I'm just not nuts and how this works. So that's the deep sky objects. Let's go into markings. If you noticed, earlier I said the planets follow this path through the sky called the plane of the ecliptic. This is true. And you can leave that on. And I have it checked right here, the ecliptic of date. Also, I have turned on the cardinal points, and you can see down here that I have south, south, southeast, southwest. But I also went into more detail by actually turning on the actual compass, so we can actually get at more accurate degrees. And it gives me an idea where I'm looking, okay, without it turning, you know, maybe at night I'm tired and I get kind of turned around looking at the sky. Now, that is pretty much the settings, and you can go in and look at these others. There's for showing, like we have our GPS system on Earth for latitude and longitude. We have one in space. It's called right extension and declination. So we don't get it confused with the Earth coordinates. It tells us when something is moving from east to west and how far north or south of the celestial equator. Imagine, I know you can't see online, but I have an old style classroom globe with me. So imagine you extended our equator all the way out into space. And that would be the equator that I'm talking about, north and south of the equatorial equator, okay? Celestial equator. You can have that turned on and off. The last, let's see, landscape. you can go through other places and take a look and look back. What does it look like from Neptune? What does it look like from Mars? All right. You've probably been online or seen on the news when they show that one of the Mars rovers takes a picture and it says you can see Earth as a dot. Well, you can do the same thing here. Also, you can use different, like a countryside setting or a cityscape. And it's my understanding that if you have a digital camera or your cell phone, you do a set of panoramic around that you can seam them together and put that into the software. So now you can have your own neighborhood around your house as the background, not the one that came with the software. So maybe our challenge this year down at the Warco is to do that, or take a panoramic of while we're up there on the roof and put it in the backgrounds of our computers. So when we're looking out, we can say, okay, if you look over this building here, here it is, look straight up and see if it actually works. The last thing I'm going to show you on this menu is star lore. Every culture has mythology, without a doubt. And this is the list that you can turn on and off. Now, some of them might not be recognizable. We're the Western, but what if we wanted to know what the Navajo saw? We can turn the Navajo on. And I'm going to pull this down, and you can see that the Navajo had some of their own features. Okay, this is the revolving male, revolving female, man with feet apart. And you can turn on, let's see, someone toss out a name here. Korean. Here's the Korean. A lot more. Officer of Tomb. Wing of Redbird. Okay. Some of them, let's see here. Let's turn on the artwork. Some do have pictures. Some don't. Some of them just didn't draw pictures with it. We can go back to like the Mongolian. And some don't have very many. And we might not be in the season that they have more. But it doesn't look like there's that much artwork. The Western, of course, has the most, because that is the most widely used. And I'm going to go ahead and shut this menu down. And so you can see what I'm doing. I'm controlling that from down here. Here is that circle of animals we were talking about earlier. I didn't get the Virgo, but Gemini, Cancer, Leo, Virgo. So here is our zodiac through here. If we wanted to, we can turn off the artwork just by using this command down here. This icon looks like a person. So you just turn it on. You can turn off the constellation names and the lines. Of course, we still have the Messier catalog. So that's controlled by this bottom one. The bottom menu controls what you're seeing at any given time. The nice thing about this is you can show children what our ancestors saw. Okay, and you can play this back. You can even turn off the landscape and the sky till now you can see the northern and southern hemisphere through the earth. All right, here's where our sun was at sunset. And you can see, let me show you a feature here. Even though we can't see this right now because Jupiter's below the horizon, if we were to click on Jupiter, it gives information on it, and I'll show you. But you come down here to the bottom, you have 4 arrows pointing in, and it centers it. And I'm a mouse person, I don't care for touchpads. I can use the roller button, and I can roll in. And if we were able to see Jupiter right now above the horizon, I'm going to stop this by hitting that, pause it. This is what we would see right now if we could see Jupiter. We would see two moons, Io and Europa on this side, Ganymede and Callisto on this side, and we can actually would be able to see if we were at UMKC, the Great Red Spot. This is not a live picture, of course, but it is a true representation for any given moment in time. So this would be the view, the face that would be our direction right now if we were looking at Jupiter. And we do see similar views to the, not this clear, but we see the striping, what we call the banding, the zones of Jupiter, and we do see the Great Red Spot using the 16-inch scope at UMKC. And what I wanted to mention up here in the corner was when you go back down to configuration, this menu here, the only one I really want to go into is information. All right. This chart here is represented here. You see what I do have selected, the name, the catalog number if it has one, its coordinates, right extension and declination, also out azimuth. So this one here tells me how many degrees around it is, from north, and how many degrees above the horizon. So looking up here in the left-hand corner, I see that it is 31 degrees or 313 degrees northwest, and of course it's below the horizon, so it's a minus 28 degrees. So if you don't understand the sky coordinates, you still understand, the sweeping coordinates of going around this way like a clock and upwards. It also tells us the distance, which is just above, just over 741 million kilometers. And that's from the sun, and from us, it's 885 million kilometers. And it should tell us also how fast it's moving. It's moving at 13 kilometers per second. So if you multiplied that by 3,600, that would be kilometers per hour through space. And each of these are on here. And let me go back. I'm going to roll back out. And I'm going to turn off the artwork. And I'm going to go to one of those Messier objects that we mentioned. All right, I'll show you how to do this. Let's go to M44, press enter. And there it's going to find it for us. If I can get this menu out of the way and see it's flashing for us here. And we can roll in. I mentioned that this was in Cancer the Crab. And it is an open cluster. I misspoke earlier and called it a globular. It's an open cluster, but you can see the photographs that they embed of these type of objects. And it tells us in here its magnitude is 3.1. That's 3. So comparatively, that is a pretty bright object, which you can see with binoculars outside the city. And the distance, if we were looking at this tonight, that light left 577 years ago to get to your eye. So that's the nice feature. When people talk about distance, we went from 700,000 kilometers for Jupiter to 577 light years for this globular cluster. So over 500 years ago, that light left to reach your eye. That's the magic of astronomy. And each of these objects that are in here that have the Messier number and just even others you can go to that are on these catalogs that have different names. Shoe buckle cluster. Let's go see what it looks like. Center it. We're going to roll in. And it's an open cluster. Someone just happened to think, hey, it looks like a shoe buckle. I'm not sure how, but you can say that it looks like another beehive in essence. So I hope you find the software useful. Venus, many of you saw this on the horizon, the brightest star that we see, right? In the evening or morning, we roll in and voila. We never see Venus as a full round globe like Jupiter, Mars, Saturn, Uranus, Neptune, because it's inside, it's between us and the sun. So in order for us to see it as a full round ball, we have to look through the sun, because as it's going around, it's going to go behind the sun and we're going to see it just like a moon phase. And so you think, well, wow, we're only seeing it this phase and it's so bright. Well, it's got a thick atmosphere that's reflecting a lot of light, and it's a lot closer than any of the planets and the stars. And in fact, right now, it is 107 million miles from 1,000,000 kilometers from us. 107,000 million kilometers. So it is going behind the sun. There will be a point where we will not see it till it reemerges from the sun. That's how it goes from being an evening star to a morning star, as it makes its trip around the sun compared to where we're at. So I've gone past, sorry, but I wanted to show you this software. If you have any questions, and we can bring up the light so we can see each other. And also in the back of the room, don't forget the people here can make a planisphere. I'm going to stop sharing for a moment. I think that will enlarge my camera, but this is one of the books I use to get have read, Patterns in the Sky. I've gone to libraries to get some books to read over the years. Of course, the internet, you go to a reputable place to get information about. There's so much on astronomy on the internet, it's phenomenal. This little book here, I don't know really how to enlarge the image of this. Okay, this is my wife's favorite little pocketbook, and it goes by constellation by constellation and has a little map and then a description of it, and even tells you what you can see in that constellation if you were out with a telescope or a pair of binoculars. And in the back of the room, those that are here, you can make a planisphere. Not like this professionally made one. We have cardstock ones, but they still work the same way. This happens to be a couple of layers. I think this one's only 2. That has an oval here that when you match the date and time up as you rotate it around, one ring has the date, the other one has the time. At that time, it will be in the oval is what you can see for our location. Now, if you go to Northeast United States, up in Upper Maine, you'll need a different one because your latitude has changed. This is for 40 degrees north. If you go up there 60 degrees, well, like I said earlier, the constellations in north and south are going to change. The only thing you're going to find most interesting about this is the placement of east and west. Okay, going around this way, we would say north, east, southwest, right? As the Girl Scouts taught me, never eat soggy waffles. Seriously, the Girl Scouts taught me that. They also taught me my very eager mother just served us 9 pizzas to remember the names of the planets. On the planispheres, west is over here. east is over here. Because what's the point of doing this? That gets tiring. So it's made to hold overhead. And north, you point north overhead. Okay, east is over here on this side. South is here, west is here. And you look, hey, there it is. And even on these, the size of the dots represent the brightness of the star. And so on the back table, Rita has some cardstock that has a front, a back, and a center. The front is the cover that you cut out with the oval that you cut out. Then the back is the center is the star field that you cut out in a circle. And then the back is just the backing that you can staple together to sandwich it nicely together. And if you want to make one of these, you can do so back there.